Let's write and balance the molecular equation for the reaction between calcium hydroxide and phosphoric acid. Let's start with the reactants. Calcium hydroxide is made up of calcium cations and hydroxide anions. Calcium forms two positive charged cations and the hydroxide anion has a one negative charge. So you crisscross those numbers to get the ratio. You're going to need two hydroxide ions for every one calcium. And this is marginally soluble. So put AQ. Phosphoric acid is H3PO4. In this double displacement neutralization reaction, we're going to switch out the cations between each compound. So one of the products, calcium, is going to be with phosphate. And phosphate, again, has a 3 negative charge and calcium has a 2 positive charge. We're going to need a 2 phosphate to 3 calcium ion ratio. Now, calcium phosphate is not soluble. If you check your solubility rules, phosphates are generally insoluble. That's going to be a precipitate. So this is also a precipitation reaction. Now, the other compound is going to have the hydrogen combining with the hydroxide, which forms water. I'm going to write it as HOH for now, because it will oftentimes help us balance in these double displacement reactions. All right, let's balance this. We're going to have two cations, two anions on each side. And this hydrogen is from the proton portion of the phosphoric acid and not the hydroxide from the calcium hydroxide. I'm keeping the cations and anions separate because if you start mixing up the oxygens from each of these compounds and mixing up the hydrogens, then the balancing is going to can get really tricky. So you want to keep them separated because all that's happening is the cations being switched between compounds. So you don't want to start mixing these elements up. Now on the other side, I'm just going to write the same order. And if it even helps, you can put a parenthesis around the OH. All right, so nothing is balanced. Let's just start at the top. I'm going to multiply the calciums on the reactant side by 3 to balance the calciums. Don't forget to also update the hydroxides. Now there's already 2 in calcium hydroxide, so multiply that by 3. It's going to give us 6. Now go to the right side and balance out the hydroxides by putting a 6 as a coefficient in front of where I see hydroxide. So I see that in the water molecule. So I also need to update the number of hydrogens in that compound. Now I'm going to go back to the reactant side and balance out the hydrogens by multiplying by 2, where I see that hydrogen species is with the phosphoric acid. And also update that phosphate. So there's my balanced molecular equation for the reaction between calcium hydroxide and phosphoric acid.